All right, so let's work through the balancing practice that we worked through in class earlier today. So let's start with number 1. We're going to do one element at a time. So let's start with nitrogen. If we look on the left side of the equation, nitrogen I only have one of. On the right side, I have two nitrogens, so we need to make those two agree. So if I put a 1 here on the right, that means I have 1 times 2, or 2 nitrogens. We draw our little net here separating the reactants from the products. I need 2 nitrogens on the left also. If I put a 2 here, that gives me 2 times 1, or 2 nitrogens. So the only thing that we balanced was nitrogens, but by doing that, we also balanced the oxygens. So this 2 times the 2 here gives me 4 oxygens on my reactant side, and on the right, 1 times 4 also gives me that same 4 oxygens. So law of conservation of mass, I have the same nitrogens on each side, I have the same oxygens on each side. This is balanced. Let's move on to number 2. So with number 2, when I start out, just as it's written, I have 1 Ag here, I have 2 Ags here. So my silvers are not balanced. If I want to balance it, that 1 tells me I have 2 Ags on the right. Again, draw our little separator. I need 2 Ags on the left. So I put a 2 here, multiplies through, and that gives me my 2 silvers on the left. So silvers are taken care of. We're going to bounce back to the right side by putting this 1 here. It multiplies through. 1 times 1 gives me 1 oxygen on the right, so I also need 1 oxygen on the left. So I need something times this 2 that's going to give me the 1 oxygen that I need on the left. So if I put 0.5, 0.5 times 2 gives me that single oxygen that I need on the reactant side. But I can't have a decimal when I'm finished, so I'm going to have to take and multiply all of these by 2. That'll get rid of the decimal. 2 times 2 gives me 4, 2 times 0.5 gives me 1, and 2 times 1 is going to give me 2. So my balance coefficients are 4, 1, and 2. They can't be reduced any further, and they're whole numbers. This is done. Number 3, let's start out in balancing our sodiums. It only shows up in 2 places, and even though it's already balanced, let's start with it. 1 sodium, because I have a 1 here, gives me 1 sodium on the left. If I put a 1 here, that also gives me 1 sodium on the right. By putting that 1 here, 1 times the single oxygen that I have gives me 1 oxygen on the right-hand side. So on the left, I need to put something in this blank that'll give me just 1 oxygen. So if I put a 1, 1 times 1 gives me that 1 oxygen that I need. Now here comes the tricky part. Up to now, the sodium was only in 2 places, the oxygen was only in 2 places, but hydrogen shows up in 1, 2, 3 spots, which is why we're balancing it last. If I look on the left-hand side, because I put this 1 here, 1 times 2 tells me I have 2 hydrogens on this side. So to balance it, I need 2 hydrogens on this side too. So from here, 1 multiplied by 1, well, that's going to give me 1 hydrogen from this 1 NaOH. Now I need 1 more from this H2. So to get 1 more, I can take 0.5 times 2 is going to give me that 1 hydrogen that I need, 1 plus 1. gave me a total of 2 hydrogens on the right. So 1 sodium on each side, 1 oxygen on each side, 2 hydrogens on each side. We're balanced, but we're not done yet because we need to make sure that our coefficients are the lowest set of whole numbers that balance the reaction. So because I have a 0.5 here, then I'm going to multiply everything by 2 so that I can get rid of that decimal. So this is going to become 1 times 2, 2. Again, 1 times 2, give me 2. And again, and then 2 times 0.5 would give me 1. So my coefficients are 2, 2, 2, and 1. Moving on to number 4. Go ahead and start by putting in our little boundary. And let's begin this by balancing our irons. It only shows up in 2 places, and I'm going to put a 1 on the left. That gives me 1 times 1, or 1 iron on this side. Here also, if I put a 1, 1 times 1 gives me that same 1 iron. Now if I go back to the left, 1 times 3 is going to give me 3 Cl's. If I go to the other side, to get my 3 Cl's, I'm going to have to put a 3 in front of NaCl. That 3 multiplies in, 3 times 1, I get my 3 Cl's. So far iron's balanced, chloride is balanced. So let's balance the sodiums now. Since we put a 3 here to balance the chlorides, we also have 3 times 1, or 3 sodiums. So if I go to the other side, to get 3 sodiums, I can put a 3 in my blank. 3 times 1 is going to give me 3 sodiums. Now, we have not touched the hydrogens, but if we balanced everything else right, they should balance also. 3 times 1 gives me 3 hydrogens on the left, and on the right, 1 times this 3 on the outside times this 1 hydrogen tells me that I have 3 hydrogens over here also. So my hydrogen's balanced out. So we have got a well-balanced reaction. With the coefficients being 1, 3, 1, 3, we can't reduce those numbers any further, so we're done. Reaction number 5. This was the hardest of the set. We'll see why in just a minute. But this is a combustion reaction. So we're going to balance this in the order CHO. So we're going to start with carbons. I've got 6 so far on the left-hand side. So if I put 1 times 6, gives me 6 C's. So I go over to the right side of the reaction, my product side. If I put a 6 here, then 6 times 1 gives me those 6 carbons I need. So next, after we balance the carbons, we move on to the hydrogens. 1 times 12 is going to give me 12 hydrogens on the left. If I go over to the right, I need 12 total, so 6 times 2 is going to give me 12 hydrogens. So far we've done C's, 6 of each. We've done H's, 12 of each. Now all we have left are O's, and just like we covered in class, this is the tricky part. The reason it's tricky is because this problem, it doesn't even show up in 3 places, it shows up in 4 places. I've got oxygen at every position. So we've got to make sure they're all balanced. So here I've got 6 times 2. So here that gave me 12 O's. And here I have 6 times 1. So that gave me another 6 O's. So in total, that gives me a total on the right-hand side of 18 oxygens. So over here on the left, on the reactant side, I also need 18 oxygens. Well, if I look, I already have some here. 1 times 6 I've already got 6 oxygens here. So from this coefficient we have left to put in, whatever we put here times 2, I'll need another 12 oxygens. That way 6 and 12 will give me the 18 that I need over here to balance with my right-hand side of the equation. So if I put 6 here, 6 times 2 gives me 12 oxygens, plus another 6 is going to give me the 18 of my oxygen that I need to balance the 18 that I had on the right-hand side. My coefficients are going to be 1, 6, 6, and 6. Can't reduce any further, whole numbers, lowest set, balanced. If you can balance 5, you can balance any combustion problem I give you. So next up, we've got problem 6. And let's see, where are we going to start? Let's start by looking at the sulfates. We balance these polyatomics as a whole piece. So don't balance the S's and the O's individually. Think of them as chunks. They remain intact. So here, this SO4 is one big piece. It's one big polyatomic ion. And this 3 is outside the parentheses, so that tells me I have 3 of these. So if I have 3 on the right, 1 times 3 would give me 3 of them, then I need 3 on the left also. So I'm going to say 3 in this coefficient, and then 3 times 1 gives me the 3 sulfates that I need. So now I have 3 on each side. Alright, by putting this 1 here, this 1 gave me 2 aluminums. 1 times 2 gave me 2. Over on the left, if I put a 2, 2 times 1 gave me 2 aluminums. So now sulfates are balanced, aluminums are balanced on each side. Let's do BRs next. So for my BRs, I've got 2 times 3. I've got 6 bromines. So over on the other side, to get 6 bromines, I would take 6. And 6 times 1 gives me my 6 BRs. Now, let's take a look at K really quick. 6 times 1K gave me 6 Ks on this side. If I look over to the other side, the reactant side, 3 times 2 also gives me 6 Ks. So we've got coefficients of 2, 3, 6, and 1. Can't be reduced. Whole numbers were balanced. All right, problem number 7. We've got, let's see, PbOH2, we've got HCl. So let's see how we're going to tackle this one. Let's start out by balancing our PBs. I've got them only in 2 places. I'm going to put a 1 in front of the PB on the left. That'll give me 1 times 1, or 1 PB. So on the right, if I put a 1 here as well, that'll give me 1 PB on the right as well. So far lead's balanced. So let's move on to balance the CLs. 1 times 2 gives me 2 CLs on the product side, the right side. So if I go to the other side, if I want 2 CLs, I need to put a 2 for my coefficient of HCl. 2 times 1 gives me my 2 CLs. So far PB is balanced, CL is balanced. So let's balance our O's. If we balance our O's, O's show up in only 1, 2 places. I'm choosing not to balance the H's because they show up in 1, 2, 3 places. They're a little more complicated. So by balancing the O's, I've got 1 times 2 times 1. You work your way into the parentheses. So 1 times 2 times 1, that tells me that I've got 2 oxygens on the left side. To get 2 oxygens on the right side, I've got to put a 2 here, because 2 times 1 is going to give me 2 oxygens. So that checks off. Now the only thing I have left here is my hydrogens. Let's make sure that they're balanced. Now I've got, and let me clear a little space here so we can see how this is going to work. Oops, 1 second. All right. I have got 1 out front here, so 1 times the 2 outside the parentheses times the 1 here means just from this PbOH2, I've got 2 H's. When I come to this HCl, 2 times 1 tells me I have another 2 H's. So on the left side total, I've got 2 and 2, or a total of 4 H's. So on the right hand side, I need 4 H's as well. I've got a 2 out front. A 2 times our 2 gives me my 4 H's. So by taking care of the Pb and the Cl and the O, we didn't have to do anything fancy. The H's were already balanced for us. Now if we had messed up on the previous 3, the H's would not have balanced properly. All right, last piece of the puzzle. Do problem number 8. This is another example of a combustion reaction. We've got a hydrocarbon here made of just carbon and hydrogen. We're reacting that with O2, and it's going to produce CO2 and H2O through complete combustion. So if we were to cover up this fuel, the C8H18, we would always see some kind of fuel plus O2 goes to CO2 and H2O. So that's our pattern. And it's key that we recognize these combustion reactions, because that's how we're going to know. We can use that dependable pattern, CHO. All right, so let's get started dividing the left and the right side. If I put a 1 here, 1 times 8 gives me 8 carbons. On the right, I still need 8 carbons, so if I put an 8 out front, 8 times 1 is going to give me 8 carbons. So carbon's done. So we move on to hydrogen. So left-hand side, we have H18. 1 times 18 gives me my 18 H's. So over here on the right, the product side, to get 18 H's, I can put a 9, because 9 times 2 is 18. So my H's checked off. The only thing we have left now are my oxygens, and this, putting a little exclamation mark here, this is where it goes wrong for a lot of folks. You got to be really careful when we're working through the oxygen. So I'm going to make a little space for us to doodle here. Okay, so on the right hand side, I've got oxygen showing up in 2 places. I've got to account for both of those. 8 times 2 is going to give me 16 oxygens, plus I've got some more here. So I've got 9 times 1, or another 9 oxygens. So 16 plus 9 is going to give me 25 oxygens total on my right-hand side. So I need 25 oxygens on the left-hand side. So whatever I put here times 2 needs to equal that 25 oxygens. So up here, if I put 12.5, 12.5 times 2 gives me 25 oxygens, and that's going to match what I have on the right-hand side. Now, I can't have a decimal place here, so I need to multiply that 0.5 by 2. So I'm going to take and multiply everything by 2 for my coefficients. 2 times 1 is going to give me 2. 2 times 12.5 gives me 25. 2 times 8 gives me 16. And 2 times 9 gives me 18. So my final set of coefficients are 2, 25, 16, and 18. Those are as low as we can reduce those. Can't reduce any further. We got whole numbers. Reactions balanced. So thank you for watching. If you have any questions, please don't hesitate to reach out.